Hey, welcome everybody to 8.2 Exponential Decay. In this lesson we're going to be doing basically the same thing we did yesterday with 8.1, only instead of our graphs being growth exponential functions, they're going to be decay exponential functions. And we're going to graph it and use our exponential decay formula to do some real-world situations like we did yesterday. Alright, so quick review. Growth, or in general I have y equals a times b to the x, but growth is happening when the b value specifically is greater than 1. And the two things we did yesterday is that it could look like this, or it could look like this. So either of those would be the exponential growth situation. So exponential decay uses the same formula, only now b is between 0 and 1. Between 0 and 1 for the b value. That's what makes it decay. And our general form of our graph this time is going to look like this. So instead of going up, it's going down, hence decay. And then if I just flip that over the y or the x-axis, it looks like this. So those are our two for decay. So one thing you're going to be doing today is just identifying if something is growth or decay. And think about what I just said. I'm specifically trying to look at the b value to figure this out. So every single time you're looking at this part right here, and you got to ask yourself, is it greater than 1 or is it between 0 and 1? Alright, so this first one, 2/3, that is between 0 and 1. So that would be decay. Growth or decay. Okay. The second one, don't be thrown off by the fact that it's a fraction. 3/2 is really like 1.5. So that is growth. It is actually greater than 0. That's why I didn't say it's a fraction. I said specifically between 0 and 1. And the third one, that is obviously greater than 1 as well, so that one is also growth. So again, you're looking at the b value. If it's greater than 1, it's growth. If it's between 0 and 1, it's decay. And now I want to tell you that when you're going to make your graphs today, you'll love this because it's the same thing we did yesterday. So the y-intercept is the same. We're going to find the point just like we did yesterday. So same steps and everything. So step 1, find your y-intercept and plot it. And remember from yesterday, the y-intercept is the a value. So for this first graph here, my y-intercept is at 3. So step 1, find your y-intercept. Step 2, we're going to find another point. And like I said in 8.1, you could use any point. I recommend you use x is 1 because it's fast. So my other point I'm going to find, I'm going to have x be 1, and then I have to find y by plugging in x. And again, it makes it easy when x is 1 because it doesn't do anything to the number. So here I've got 3 times a fourth. Use your graphing calculator if you want to, but 3 times a fourth is 3/4. So it's 1, 3/4 for my answer. So step 1, y-intercept. Step 2, other point. Step 3, draw in the curve. And then let's find our domain and range and our asymptote. And note, this is similar to what we did on 8.1. So the asymptote starts at y equals 0 if nothing is shifted. And then this is like what we did before. So the domain, the x values, are still all reals. And again, if I made the world's largest graph, all the x values used is going to be infinite. All of them are used. So that's why it's all real numbers. The range is the y values, and if I look at this, these are all y values above 0. Above y is 0, so y is greater than 0 for my range. Go ahead and pause and try to graph part B here. Okay, if you are done, you should have had a y-intercept of -5. And then for my other point, when I put in a 1, I end up with -10/3. If needed, change that to a decimal just so you can kind of see where that's graphed, but that's at -3.3 approximately. So that's where I'm trying to graph it here. I've drawn in my curve. The asymptote is at y equals 0. And the domain is all reals. All right, so again, the domain is then all real numbers. And check out the range this time. So as you can see, again, it's below the asymptote, so that means that's going to be y is less than 0. And you can see how these graphs are very similar to what we did in 8.1. So we're going to now talk about the shifted functions, and the rules for shifting exponential decay is the same as it was for exponential growth. So just a quick reminder, here was our general format. For the h value, plus meant left, minus meant right. For the k value, plus meant up, minus meant down. And I'm going to teach this the same way, and again, only your answer graph is required, so you do not have to do the one in between. But the method I use to teach this is step 1, graph just y equals -3 times 1/2 to the x, for this example, for example, so without the shifts. And again, I want to graph my y-intercept, which is at -3 this time, and then I want to find another point. So my other point I'm going to use at 1 for x just because it's easy and convenient, and to find the y value, looks like I end up with -3 times 1/2, which is -3/2. So 1 comma -3/2, and there I go. So that is my graph before any shifts happen. So then I'm going to look and figure out what my shifts are. I am thinking left 2 and up 1. The up part is what tells us how to move our asymptote. So I'm going to move my asymptote up 1. So my asymptote for my answer graph is going to be y equals 1. And then these 2 points I'm going to move left 2 up 1. So left 1, 2, up 1. Left 1, 2, up 1. Draw in my new graph going up to my asymptote. And then for my domain and range, the domain is still all reals, and you may have noticed by now for every exponential graph the domain is actually always going to be all reals, so the range is the only part we really need to worry about. For my range, I'm going below my graph, and my asymptote has moved up 1 unit, so it's going to be my range, my y values are y is less than 1. If you would like to try one, go ahead and pause and try the next graph. If you don't feel like you're at that level again, I am going to teach it like I did the other ones in 8.1. So step 1, I'm going to graph this without the shift. So I am thinking y equals 5 times 1/8 to the x. So 5 is my y-intercept. 1, 2, 3, 4, 5. And then I'm going to find another point, plugging in a 1 for x again. So 5 times 1/8 is 5/8. Just do the best you can to graph that. 1 comma 5/8, somewhere around there. All right, I'm going to draw in my curve. Now I'm going to figure out my shifts. So in my head I'm thinking, okay, h is -2, so I'm thinking right 2. K is +3, so I'm thinking up 3. So this time my asymptote moves up 3 units. 1, 2, 3. Here's my new asymptote at y equals 3. And then each one of my 2 points I'm going to move right 2 and then up 3. So right 1, 2, up 1, 2, 3. Right 1, 2, up 1, 2, 3. Go ahead and think about the domain and range if you haven't done so yet. So there's my asymptote at y equals 3. So again, like I said earlier, the domain is always actually going to be all reals for exponential graphs. And then the range, this time it's moved up 3 units and it's above the line, so y is greater than 3 for the range. Pause it if you need to, and then when you have that written down, flip to the back side. Alright, now we're going to do what we did yesterday with that exponential growth, only we're going to apply it to decay situations. And it's actually the same formula we learned yesterday, but instead of something increasing, it's decreasing. So I'm going to say 1 subtract our rate. Everything has the same meaning though. So A represents my starting amount. R represents the rate as a decimal. T represents the years since the starting year. And again, it could be months or something, but usually they use years. All right, so here's my first example. You're going to buy a new car for $24,000. The value of the car decreases by 16% each year. I want to write a model for the value of the car, and then step 2, we're going to estimate the car's value after 2 years. All right, so just for the first part, I'm finding a model. Remember, when you find a model, T stays T. All we need to do is fill in A and R. All right, so A is my starting amount, which I see is 24,000. My rate is 16%. As a decimal, that would be 0.16. And then remember, T stays T. So my final answer for my model is y equals 24,000, and then 1 subtract 0.16 is 0.84. So that's the first answer. And then step 2, it wants us to estimate the car's value after 2 years. So that means that time is going to be 2. So I have 24,000 times 0.84 to the second power. And when I plug that all into my calculator, give it a try just to make sure you can do your calculator entry correctly, but I end up with 16,934.40. All right, step 2, we're supposed to estimate when the car has a value of 12,000. So I didn't say this, but the y value in this situation is representing our ending value. So we're basically trying to figure out when has the car value split in half. I'm going to set that equal then to the model we created. And basically my missing variable right now is t. We're actually going to learn how to solve for t later on in this chapter. Right now we don't know how though, so we're going to have to do some guess and check action. So I am going to guess and check, and I probably spelled guess wrong because I do that sometimes. You can make fun of me tomorrow, that is allowed. But go ahead and guess and check. So try 2, try 3, try 4, try a few things for t and see what happens. Actually, we know it's not going to be 2 because it's only decreased to 16,000. So you know it has to be 3 or 4 or 5 or something like that. And after you guess and check, so let me guess and check here. I plugged 3 in, and the answer was 14,224.82 high still, so I'm going to guess 4. I end up with this, 11,948.9, so close enough. So when does estimate when the car has a value of 12,000? After 4 years. After 4 years, the value has been cut in half. All right, second example for word problems. Now we're going to buy a new car for $23,000. The value of the car decreases by 15% each year. We want to write a model, estimate the car's value after 3 years. This would be a good time to pause and try this one on your own if you feel like you got it. Otherwise, follow along with me. I'm going to plug in my value, and I want to this time decrease by 0.15. So my final answer for my model ends up being like this. I want you to plug in 3 now and see what you're getting for your answer. Check your work, but you should have approximately 14,124.88. Okay, and part 2, we're going to estimate when the car is going to be half of the original value. So half of the original value, half of 23,000 is 11,500. So now we're going to do the same process we did earlier, where we're going to do some guessing and checking action and try to figure out approximately what t is to get 11,500. And we know it's going to not be 3 because we already tested that. So go ahead and test a few things here. What ends up happening is it's somewhere in between 4 and 5. So we're going to approximate that as 4.5 years. All right, at this stage, we had some extra time in this video, so I threw some problems on here for you to try just to see where you're at with some math from your past. So go ahead and hit pause, do these problems, and then check your work. And when you unpause, I'm going to have the answers showing. All right, so these problems are all things that you need to know how to do basically to successfully say you've completed Algebra 2. So if you have questions on any of them, we can do them in class first thing tomorrow. Thanks for listening, and we'll talk to you soon.